Hello everybody, thank you for coming. My name is Svetlana Barkanova. I'm a physics professor here at KD University. And right now, I am going to give you a very brief introduction into astronomy in just 10 minutes. Astronomy is the scientific study of a physical universe and objects in it. Stars, planets, asteroids, supernova explosions, the evolution of a universe itself. This is astronomy. It comes from a Greek word, astronomia. Astro means star, and nome, distribution, arrangement. But the modern astronomy is so much more than just distribution. It is physics, the physics of stars, the physics of processes. Everything in our physical, observable universe. Not to be confused with astrology. Astrology is the study of movements and arrangements of celestial objects in an attempt to predict their influence on human affairs. It comes from a Greek astrologia, astro, stars, logia, doctrine, theory, science. But astrology is not a science. Actually, don't mind astrology as long as you understand it's not science. It's a conversation starter. It's a way to make human connection. I'm Pisces. Hi. But it's not science. Let's talk about scale first. Here's me on a launch pad in Florida. This is our starting point towards the cosmic exploration. Now, you can see me right here. I'm pretty tiny. In metric system, I'm 1 meter 64 centimeters. Compare that to the size of our planet. That would be me multiplied by a factor of 9 millions. Now, let's compare our planet with the size of our star. So that would be the diameter of our Earth by 100. Let's continue to zoom out. Our planetary system, even Jovian planets, which are pretty gigantic, is much, much smaller than the size of our Sun. And if you look at terrestrials, Mercury, Venus, Earth, Mars, they're just pebbles comparing to everything else. They are pretty tiny. Zooming out, here's our Sun. Here is the size of our solar system. The size of our solar system is about 100 astronomical units. An astronomical unit is defined as the average distance from our Sun to our planet, which is 100 million kilometers. Our Sun by 10,000 times. That's the size of astronomical unit. As you zoom out to galaxies, astronomical units are no longer enough. A typical galaxy, here is a spiral, would be about 100,000 light years. A light year is the distance traveled by light in 1 year. If you look at the group of galaxies, a size of that group is about 1 million light years. So it would take light 1 million years to travel from that point to, let's say, here. 1 million light years. This is a Hubble deep field. Some say this is one of the most important images ever taken by humanity. Every dot, blimp, or smudge in this image is a galaxy. Now, most of them, as you can see, are slightly reddish. That means that they are redshifted. That means that those galaxies are moving away because our universe is expanding. You can see that for yourself, the expansion of our universe, right in this image. Have you heard of a galaxy dance? So, the galaxy is moving away. It's moving away. At the same time, it would be rotating, right? Here are my spiral arms. So try moving away as you rotate. Okay. Try that next time you go out dancing. Galaxy dance. Our universe, our observable universe, is 93 million light years. That's pretty enormous. If you want that in miles, 5.5 10 to the power 23 miles. It is large, but it is not infinite. We can actually account for everything in it approximately. We know it has 10 to the power 11 galaxies, 10 to the power 21 stars. We can even estimate the number of photons. And it has a beginning. It started from a single point as a Big Bang, converting energy into mass. Starting the particulate evolution, when you have formation of elementary particles getting together to form atoms. Atoms get together to form galaxies. When you have stellar evolution, then planets. Our own planet Earth, our own solar system, formed about 4.6 billion years ago from a gigantic cloud of interstellar gas and dust, which by some reason started to contract. If you look right here at Carina Nebula, you see those pillars of gas and dust. Those are the star-forming regions. The stars are forming there right now. And this is an ongoing process in our Milky Way galaxy. Stars are forming all the time. So as this cloud is contracting, it's going to flatten out and spinning up faster and faster. Eventually, from this disk, you have a formation of a planetary system. Formation of planets is actually a natural byproduct of stellar formation. Most stars are forming with planets. So you have a star in the middle. Stars come in pretty different sizes. Some are quite small, like our Sun. You can see here for scale, this is our Sun. Some are enormous, like Antares. Antares is 300 times larger than our Sun. They come in different colors. I think they're like dogs. Different sizes, different colors. But they all do the same thing. Every star, small or large, is a thermonuclear furnace. They're fusing hydrogen into helium, producing enormous amounts of energy. Bigger stars, something which is 500 times larger than our Sun, can do even better. They can fuse past helium into carbon, oxygen, neon, magnesium, everything up to iron. And as they run out of fuel, they will collapse, then expand, going into supernova explosion, distributing all that material they just made back into galaxy. This is a supernova explosion remained. You can actually see for yourself all that material just expanding. The universe recycles. You have formation of planetary systems, stars and planets from interstellar medium, gas and dust. Stars form, they evolve, they fuse elements together. Some of them die supernova. The elements go back into galaxy, starting the new generation of stellar formation. And most elements in your body are actually made out of stardust. We're all made out of stardust. Isn't that fascinating? If you want to learn more, take an astronomy course at Open Acadia. Thank you.